Bam.
This is Scott Martin, and you're watching The Breakdown Show.
Yeah, the Break It Down show brings you a guy named Scott Martin that I met along the way. I meet a lot of interesting people along the way. I'm trying to go live on Facebook, and it's just not letting me do it. So, oh well, whatever. I'll have to catch up. So I meet a lot of people along the way, and Scott is one of these people that has developed an interesting product that I thought would be neat to talk about as we're all trying to look, Scott, we're always trying to figure out how do we be better stewards of the earth? How do we use technology to our advantage? And we love to talk about AI and figure out like how, what are we going to do to AI is going to take all these jobs and everything. But the reality is it's in all the nooks and crannies that we move forward. I mean, I used AI to help me. I just published this blog thing. As a matter of fact, I'm going to put a link up in here right now. Anybody who wants to read, I literally just, while you were waiting on me, I was wrapping up publishing something. I took it over to the AI side, and I'm like, here, try to write this thing better than me. And it didn't really do it. And so I'm like, all right, cool, I win. but I can't do what your product does. And it's 1,000 of these little things that knock the dents out of what the future looks like that we don't think about today. I mean, you and I are old enough to remember like the home computer was going to store all of your recipes. Stuff like that, right? But it's wildly different, and it controls our life. We had to switch over Wi-Fi providers, and my phone wouldn't work for a while today because our Wi-Fi was down, and it was frustrating. I'm like, no, I'm trying to download the app, which I don't want more apps on my phone. All these things, right? So let's get into what InteliGlas is and what it does and what the future looks like.
Awesome. Well, InteliGlas is a smart building platform built for old buildings to make them smart. And we grab anything with a digital footprint in the building and retro commission the building to become smart. So we utilize occupancy of the building. So we do count occupancy in and out of the building. And we do a 40-year predictive analytic on weather. So we kind of know what's coming at the building and determine how the thermal exchange of heat gains and heat losses go in the building to be able to make it function better. And also knowing where the bodies are in the building helps you turn off and on lights and things like that. So it's office buildings, medical office, and life science buildings are really our specialty. Those buildings by themselves, which there's over 650,000 of them in the U.S., eat up about 41% of the power grid annually. So if you built brand new buildings today and they were LEED certified, platinum, the best buildings you could build, the carbon footprint would never change. But the idea here is to make the carbon footprint go the other direction. And so that's kind of our mission. And when we started on that, it was, trying to just lower utility bills and as an adjunct, and then it was carbon reduction. But then there's a whole host of other things that occur, saving people time on, engineers. We save them almost an hour a day. And, that's overtime hours. That's about $30,000 a year for an engineer at a building or even a property manager. So there's a host of other things that have become an adjunct of value added and value creation that we've done as well, which is kind of fun.
When people say, I saved you an hour, right? Like, and this is not me coming back at you, but I have to ask, right? Like if you go to the golf convention, you walk out, you've got 250 strokes back on your game. And you're like, but I still suck. So, people are always giving me an hour back and hours back on the time I spend on my show, for example, right? We're going to help make it easier, but you're giving me more work, right? So yeah, you're going to give an engineer an hour back. And I believe you on that, but is there more work in that hour? So they end up spending 2 hours to get an hour back. How do you guys quantify that?
Yeah, interesting. So just the nuance of tenants calling an owner or a property manager saying, could you turn the cool air on? We need some more cool air. Turn the temperature down, change the setting. And it takes on average about 20 minutes for an engineer it's got to go through the channels, right? So the property manager to the engineer, then he might actually be, it might be a campus of buildings. You might have to get in a golf cart, go to another building, get on the BMS system, type into it. So, on average, it's about a 20-minute turnaround to make those hot and cold calls, just to change the temperature. And that's not, walking the building or going in a space and identifying a problem. It's just simply, addressing somebody's concern, somebody's, need. And so the realities are, that's the simple low hanging fruit. The other aspect of it, when we talk about AI, you need teaching moments for AI. And so our platform, we actually give the tenant the ability to change their environment. So, make it hotter, make it cooler. Every owner that we've gone to, all of our customers have then said, no tenant is going to have any control of their space. And now we're at 55%. 55% of our clients have said, all right, I get it. I trust you. You've earned your trust with us. We can do that. And part of that is the buildings with engineers, you got to earn their trust as well. So letting them know that you're doing the right thing. And so the engineer always has priority with us. So they can run the entire show as long as they want. But as they get familiar with the platform and we're setting subtle responses back, or maybe a rule that they've created that sends a note saying, hey, the humidity's gotten too high in this particular floor. As they relinquish the control, then the artificial intelligence then can make the change that they want. And so once that occurs a couple of times, then all of a sudden the engineer's like, oh, this is great. Yeah, I don't need to be bothered by that little thing. So it allows them the bigger and better things to go on to. And that's a whole other, side of the equation. You get into like mitigating risk. So it's like keeping the guy off the ladder. You don't want him on the ladder. You want him doing other things that are more, how about this? An engineer walking a building and saying hi to the tenants, and the tenants get to say, oh gosh, I get to see you. That's nice. Nice to, he's getting a little socialization, but he gains confidence to walk around the building knowing that the building is in good shape. The air's clean and the temperature's just right and there's no problems and that type of thing. So, and I think as an ownership of a building, that's kind of a way of building a brand, is saying, hey, our engineers walk around with confidence. They're talking to the tenants,
Yeah. We've seen elevators get a lot smarter. When you see a dumb elevator, oh my gosh, like, oh my, it's interminable. I don't even know how we used to wait for elevators before because they're so bad. But you barely even touch a button now. Like you do a region and they're so fast. Is this just an advancement of that overall thinking for a building?
Well, I think there's been a lot learned, like in California, for example, when we had earthquakes, we had elevators that were, that went up instead of going down. And that creates the counterweight swinging through walls and created a lot of damage. So part of that is just fundamental engineering, taking some big risk off the table. The other thing is just simply putting the elevators in a hovering position on a floor that's maybe well occupied, that's going to, has more frequently people, riders coming off of that floor. So some of it's that. But the other thing, as it relates to the overall scheme of things, and there's some great technology, again, everything's just kind of siloed. So the platform here is to take everything and make it sing together. It's like running a giant orchestra. So when an elevator moves, it's actually pushing and pulling air off the floor. So it does change the static pressure of buildings. The technology and traction, they've gotten certainly faster from floor to floor, but that means there's pushing and pulling more air faster. Drawing, as the elevator goes up, it draws the lower level air, sucks it right up into the building. So part of that is, from a controls from an HVAC perspective is keeping that static pressure the right way where you're not blowing the doors out of the lobby, for example.
Right. Yeah, that's interesting. I was thinking about a different aspect of it. So, a smart building is not only having smart elevators, but you're also tying in the HVAC and you're tying in other aspects of this together. And the more systems that you commingle, I mean, I guess we're talking plumbing too, right?
It could be plumbing. We do watch where water goes, or how much water is consumed in total. But yeah, leak detection and things like that. You want to know if there's a problem. For example, the it's a Friday afternoon at 3:30, and the engineer decides he's going to go take a leave early, which they typically will do on a Friday because they get in at
Right.
5:30 in the morning.
Yeah,
So
yeah.
they leave, and all of a sudden there's a leak, and if there's nothing there to notify them, it's not until Monday morning they get back at 5 in the morning that they realize that the water has leaked down, several floors and created, millions of dollars of damage. So it's getting that alert, which we've done that before. We've alerted somebody who says, "God, I just left the building 30 minutes ago." It's like, well, I'm gonna have to go back, and thank God I went back because, I saved millions of dollars of damage in the building.
Yeah. Yeah. And I mean, that's a big thing, right? Because not only is it millions of dollars in just whatever repair and everything else, inconvenience, but also risk and, everything. Like you got a bunch of people walking around in a wet area that brings in the opportunity for mold, slip and falls. I mean, that cone of cost just can really get wide fast.
Yes, very much so. And we've actually had Alliant Insurance and Hartford Insurance look at us, and they said, "Well, if you're going into buildings with this system, we will certainly look at lowering our premiums." And today, it's not significant, 1% or 2%, but if you have a portfolio and you add all those together, that adds up pretty quick. If you can, help save. Like I said, our famous line is "keep guys off the ladder." But also keeping people from slipping. And black mold is a real deal, definitely in Florida and the South where it's hot and humid. So,
well, and if you plumb for a living, that building is a living thing. And if you fix something somewhere else, there's going to be, I mean, you're never going to stop plumbing in the building. It's not ever going to be a complete system. Same thing with electricity or anything. There's going to constantly be, and the building doesn't have to be very big either, where you will never stop repairing, maintaining, replacing things. It'll never stop.
right. The whole idea is to help the vendors see things, from, how about this? You can actually look at the building from your office from a vendor's perspective before you get in the truck. And I've actually had a couple of owners of an HVAC company, for example, and they said, we run in a 2-hour window, a 4-hour window, or an 8-hour window. And so, they would catch their guys, go to the building, figure out what was going wrong, then have to go off-site, buy all the parts and bring all the parts back to the building. But during that time, they might go visit their girlfriend at the bank, grab a bite to eat, and then all of a sudden, that 4-hour job just turned into 8-hour day. And so the owners of the company says, you just made me more profitable by giving the ability to look at the building systems before they even leave the yard and make sure that everything's, getting changed either there remotely or, putting the right things in the truck before they roll out. So
if I own a series of buildings and I've hired Dina's HVAC company and I've got your product, does Dina's HVAC crew have tablets that communicate with my buildings as they run around? And are they able to predict, like, oh my gosh, Pete's gravastats valves are failing in buildings 6, 20, and 32. We need to order these parts and get over there this weekend because, whatever, these gravastats valve are going to give out in the next 20 hours.
Yeah, they'll be able to pick up anomalies like, a hot water valve stuck open. that's blowing hot, or a damper that may be stuck at
Yeah.
50%, 100%, or whatever. But those anomalies, they can self-check them, so they can change a set point and see if it's actually getting a response right then and there.
Right.
So it's not just reading analytics; it's actually sending controls back and actually seeing if you're getting a response. And so that's what the vendors can do remotely with us. And we run everybody through our portal, and so they have their own set of user identification setup and passwords. And we try to cyber secure the building down. We're not cybersecurity experts, but we harden the asset and make it really difficult for that to occur. So VPN tunnels and certificates and so forth that we use, and then just try to limit those pages only to be seen by a vendor. Allow them to see that. And then also the engineer has the ability to say whether he wants them to make a control, have actually editing ability, so to speak, or just view only. And most vendors will get the full enchilada to be able to make changes and really test it out. So
is this a taking the Internet of Things and putting it into one platform, and then putting it in a galvanized tube so that nobody can get into it? Is that what you're describing? Because I'm learning as we go along.
That's a pretty good way of describing it. Actually, I haven't heard it stated that way. What makes us a little different than everybody else is we're not just producing data and giving data out to owners and letting them drown in it. So we actually do put some hardware in. So like this little guy here, it picks up luminosity and temperature and humidity and CO2 levels. It picks up motion. So we know we can't count bodies with that particular device, but we will put that in 1 per 1,000 square feet, for example. And we'll know in a sea of cubicles if there's bodies moving around, and if there's we've taken some of the best reports that are out there. So for example, like Berkeley studies on luminosity, and we know the right lighting looms for an office environment. Same thing for air quality, CO2, the temperature, the humidity, what's the right formula for higher productivity. And then go all the way to the other side of the equation for like the air conditioning standards, which is called Azure. And they have a whole set of their own standards. And so putting those together and creating algorithms with that. And then the Department of Energy, the Department of Energy's got a whole set of standards. So it's, you talk about AI, and so AI is only as good as the data that it gets back. And you want to, and certain algorithms that we write, they're layered, right? So for example, if I'm hot, I want it to blow cool air, but maybe I just need more air. So maybe it's just more airflow coming in. But it's not just that, it's how many bodies are in the space. Is there like 5 other bodies next to me and they're putting off 500 BTUs of heat per hour?
Yeah.
Or am I in the southwest corner of the office and it's a 90-degree day going to be 105? Or is it going the other way? So the engineers are smart guys, but they can't think about all this stuff, and they're only working there 8 hours a day or 10 hours a day, and the building is a living, breathing thing for 24/7. So that's the kind of the fun thing that I've had to learn about creating this opportunity, this company is the fact that there is an after. The building does speak to people after hours, and if you listen, it's giving you some hints about what it needs. So
I love it. I love it. This is interesting. So I mean, a lot of this stuff is sort of like, we know a lot of it. I mean, if you're on the southwest side of the building, it's going to be hotter in the afternoon and most of the day than the north side. And so positioning how your office flows and works is a thing that we know about already. But automating those sunshades that come down at a certain time,
right?
I know, like, I love the adorable little lady that's like, I'm from the climate people, and we want your house to be 85 degrees. And I'm like, you have got to be insane. That's great advice for your goal. My goal is productivity, and I need the place to be, X plus or X minus whatever you think that is, right?
Yep,
So
72
how
and a
do
half
you?
degrees. That's what they tell us.
Yeah. So there are all these things, and how do you take what the current thinking is and make the best environment? And look, it's always going to be that the dudes run hotter than the ladies, and the ladies are going to have blankets and sweaters at the office, and so you have to manage that part of it. I mean, is that something that can we make microclimates like in our car where my side's 72, her side is 75 when we're driving?
Yeah, that's kind of the fun thing that we've learned is you could have 5 suites on a third floor, and they
Hmm.
all don't need to be all 72 degrees. You like them to be, but we just know
Right.
that it's impossible. You have north facing spaces and east, and the morning it gets the sunlight, and we just know the daily changes. But yeah, so you can microclimatize them for certain, and that has to do with knowing where the bodies are in a space, and
Yeah.
knowing humidity and temperature obviously is key. But that's why we do a 40-year predictive analytic on weather. We
Yeah.
want to know what's happening throughout the day. And you could have single pane glass, you could have double pane glass. So certain
Right.
aspects of that change the heat up and cool down. It's interesting. We talk about the hours during the day. So let's talk about the hours, like in Chicago, for example. Everybody
Sure.
leaves the building and it's a toasty 71 degrees at 6 o'clock at night. And then they step out and it's 10 degrees and it's going to go to 10 below zero. And the building could freeze up pretty quick, right? You got fish and aquarium, you got you know restroom plumbing pipes and all that stuff. So they don't ever let the building get really, really cold because it just would take forever for it to heat up the next morning. So they have this
Right.
reheating system that usually in a lot of buildings. And they usually run on power, on just energy alone, and it's just extremely expensive to do those. But we were getting some pushback about how quickly it takes to heat up a building in the morning. So they come in and it's like, oh, it's always 2 hours. You always got to preheat the building and get it before the first person gets there. And the way the office buildings leases are written is it's at 6 o'clock in the morning, you turn it on, at 6 o'clock at night, you turn it off. Well, how about if the first person doesn't come in till 8 o'clock in the morning, and the last person that leaves the building might leave at 4:30 in the afternoon? So why can't you adjust the building dynamically based upon the human need, right? So
Right.
we're able to do that. We're able to pick up some patterns to be able to figure that out for heating and cooling. But more importantly, when you have an engineer that's kind of like you're trying to earn his trust, and you say, hey, look, finally we've gotten to a graphic that says, let me just show this to you. It actually takes your building 58 minutes to go from 62 degrees to 72 degrees.
Right.
Again, you're talking about big buildings, 100,000, 200,000 square foot spaces. So, and every building is different. They all have different characteristics to them. But when you can demonstrate that to an engineer and say, oh, okay, well, geez, all right, I now believe you. That's when you can start to, you can start to get some big savings on these air conditioning units that run.
Yeah.
So we ran a study for like a 60-ton unit for in the middle of the summer. We just did it on a summer day to figure out what it was going to cost to run.
Yeah.
It was $280, at least in California in terms of major energy cost. But
Right.
$280 an hour, even if it was $180 an hour for one 60-ton unit, for 1 hour, you start to add that through the course of a month, it adds up to
Yeah.
be some big dollars.
Yeah. Can like about stadiums and domed stadiums and whatnot, and what it takes. Like the A's are going to build a stadium in Las Vegas, and what it takes to keep that thing regulated, and what you might do pre-planning wise, and working with you guys to help think through that. Are you guys able to get in front of a problem like that? Like, should the A's be engaging you guys right now, trying to say, hey, how do we make a smarter stadium?
If we did stadiums, yeah, that would be absolutely wise of us. In fact, I just was reading some articles about like a Alliance Stadium that was just built for the Raiders there, and then they it's one of the few stadiums that is actually trying to use green energy to be a zero carbon emission stadium.
Yeah.
And in Paris right now, that's their whole deal. They're going to really try to drive like wind powered energy and push it to the stadiums that are operating the various venues for the Olympics. And I just think that's really, really brilliant. But it takes a heck of a lot of planning, a lot of ingenuity.
Yeah.
Again, we could do new buildings all day long in our sleep, but the problem really is it lies out there with all these existing buildings that they need attention.
When we look at thermodynamics, right? Like there's a lot of rules there. There's probably another one out there we're not even accounting for. But when you have an existing power system that works and you try to switch everybody over to electricity, and electricity is hyper expensive, it's just really hard to make it work, especially on an old building, that's built with different materials from a different time. And then it's historic. And you're like, don't you dare change this thing. It's historic. And all of a sudden, you have a real problem. So I don't know, how do we address this with old buildings and deal with some of this stuff? Because I'm all for like making better decisions and all that, but this company's gas stove systems throughout the entire building, is it really the problem, or is there more fruit somewhere else that's lower hanging that they should be focused on instead of kicking out these old gas stoves that are actually pretty efficient overall?
Yeah. So there's a lot of topics in that.
And look, I'm just ranging around because I'm trying to understand what you guys do. But let me just take you off the hook a little bit. I know, like, our environmental policy here in California, in the United States, we're trying to reduce the damage that we have in the environment. So here in California, we're trying to reduce our natural gas consumption, and we're trying to increase our battery consumption, but we're still tied to the power company. So you can get solar, you can get batteries and all that stuff, but you must be tied to the grid. Like, well, that seems inefficient. Oh, and by the way, we're going to buy all our oil, despite having plenty of energy in this state, especially in the United States, especially as a nation. We have all the energy we need. We're going to import it in ships that burn bunker fuel from Asia and Africa, right? Burns, one ship burns more than all of our cars in our state all by itself. So when we see policy that's meant to fix the environment, offshoring our pollution, offshoring our dangerous production, and not keeping that money here, I wonder, like, are we even capable of making decisions that allow us? I'm not trying to make you make a political statement, but when you look at the engineering of these problems, one or two bad decisions and all of the gains, because thermodynamics are very demanding, they're all gone.
Yeah. Well, it's interesting. Last night, 60 Minutes, the state of Wyoming is doing some incredible stuff. I mean, they're really setting the benchmark of things. And it's not, they're all not tree huggers there, but, let's face it, they mine a lot of coal. But there's carbon capture, and they're doing some great things with these new carbon capture technologies that, burn the carbon, burn the coal, it's cheap, and actually capture the carbon back. So that's some really interesting technology. The whole notion of solar, which is kind of funny. We went into a building and they said, "Oh, we got solars hooked up, but gosh, it's just something's not really working here." And it's like, the inverter's been off, and I don't know how long it's been off, but you might want to turn that on. It might help, the solar work. But my partner, worked with a lot of these Superfund and landfill sites that the government had, over 600 of them. And they're in these, godforsaken places that no one would want to drive to. And yet they always wanted somebody to drive in the middle of the desert, 40 miles, each direction, to start up a flare station and do this and that. So he built this remote monitoring and control. We go in, remote, just as we're doing in our backbone of our product.
Yeah.
And you start up a flare station and you turn it off, and you're able to read, the carbon and the temperatures in the air and all the various, whatever measurement you can think of. We
Right.
just actually had somebody who says, "Hey, I want to know what the water quality is in my cooling tower." We're paying these guys an obscene amount of money. It's like, we got a sensor for that, put it in. And so now the engineer is able to look at it instead of paying somebody else to go on the rooftop every quarter and give them an assessment of what the water is like. So the technology is out there, and some of it could be expensive, but it's coming down a long ways. And then the other aspects of it is having it all work together, right? So you mentioned harvesting, the sun. So why can't the window be tinted? Why can't the shades go down? And there's, like I said, there's some great products, but everything's built and they're all so siloed. And so if you can just kind of take and put all those silos together, where the elevator is talking to the lighting and the lighting's talking to the air conditioning, and even like sump pumps and like subterranean garages with sump pumps on it. They don't know whether the motors are working until it rains, and then it floods the garage, and the next thing there's an insurance claim. It's like, well, you can test these things remotely, once a month, and make sure that everything's working. So we're trying to shape behaviors of tenants and how they utilize their workplace, make them more productive, obviously, and but also be more cognizant of coming and going out of a space, turning on the lights, turning off the lights, that type of thing. Or, and an interesting thing is, it's found that the warmer the space is, like 74, 75 is actually like the right high productive temperature for a work environment. It's not 68 or 70 degrees.
So there's some adaptation on the human side that we have to get used to.
Yeah. So there's some cool stuff. We actually looked at, how people dress. So if you go to work in shorts, or you go to work in a 3-piece suit, or you go to work in an athletic, training jacket, the sweatpants and sweat jacket, that type of thing, you can actually, we've been playing with that. How does that change the algorithms for comfort? So the definition of comfort is, it does vary from person to person, male, female, but also the way that they dress, and keeping that in mind as well. So we're doing some fun things. We're trying to shape behaviors. For example, here's another one. People in the workforce. There used to be a lot of Vietnam vets, a lot of war veterans that were great building engineers. Well, they're aging out population.
Right.
And the younger generation wants to go to school to become engineers, but not building engineers. They don't want to turn wrenches or screwdrivers. They want to program stuff.
Right.
So we've actually gone out and we're trying to work with a school in Florida that actually is a gaming school, but teach and award a buildings engineer certificate. And so our platform is intuitive enough that a computer gamer could get online and become a master engineer for a number of buildings and run buildings on our platform. So we're trying to shape that environment coming down the future, for young jobs, for young kids to be employed and be green.
Yeah, right. And that's the ultimate goal, right? To be more green, to waste less energy, right? We still need the same amount of energy. Heck, we're consuming more energy than ever before. There's another conundrum, we don't like, hey, we need less energy. That's not how it works. We want more. I mean, I've got a camera, I've got a laptop, I've got a light, I've got all these things right here that Wi-Fi takes energy. So all these things that I didn't need 20 years ago, and here they are. That's how I do my work. When you look at something like, I'm curious about, like, Vegas is such an interesting place to me. It has the most congested, giganticest hotel, 2.5 mile strip ever. And it just gets bigger and bigger and bigger. I mean, It used to be back in the olden days, 20 years ago, the Luxor was a really big hotel. Now it's dinky. And you think, man, how do they manage all of that? All of the food that has to get brought in, processed, eaten, pooped, all that stuff, all of the water, all the waste, not just black water, but all of the waste, all of these things, all of these miles of pipe, all of this cooling, all of these elevators. It's an enormous amount of energy. I don't know that you could put enough solar panels on top of these buildings to match all the demands. I mean, and everybody is going there to be opulent, outsized. It's like it's not a real life; it's your Vegas life, and so the TV is on the entire. So,
Yeah.
what are your thoughts on how you guys would help at a place like I don't know, the Bellagio or this new Hard Rock Hotel that's going to be shaped like a guitar?
Yeah. Well, there is a reason why the Hoover Dam is so close to Vegas.
Yeah,
There's a lot
yeah,
of hydropower, and
yeah,
that is a cheaper, greener power of source,
right.
of course. Yeah, the number one problem with hotels, they run on two different software systems. If you can picture this, so
Okay.
when someone you go online and you say, I'm going to go to Vegas this weekend and I'm going to get a room at Bellagio, and so
Okay.
you log in and you sign up for the room, and so they it goes into their booking system, and that booking system just pigeonholes people where they need to go. And then you have the operations side of the building that runs the lighting and the air conditioning systems and the elevators and all the fun stuff that we deal with, the pool and all that. And it sits by itself. So imagine this, if the booking system could work and along tandem with the operational system, and let's just say you start book the second floor, the third floor, you book floors, 2 through 10, and they're full. And, you might leave 11, 12, 13 vacant. But guess what? When you save energy, when you're green, you don't have to turn on floor 11, 12, 13, 14, 15. You just need to work the other. So if you can book the floors and have a full floor and create vacant pockets. And, the cool thing with Vegas is that they do actually pretty cool stuff with the construction is they have, damper on each of the floors. They just turn the damper off. So the floor is off and they can push that air somewhere else in the building. And
Right.
I think that's there, there's that stuff's coming down the road, but it's simple things like that again, these are things that I never really thought about until you sit down and ask, Rosewood Resorts, hey, could you help a hotel? Yeah, we could help you on a hotel.
Right.
So some of it's just sometimes monitoring, gas and water and things like that, so that we see the consumption. Like California, you mentioned is this AB 802. It's just all about benchmarking. But you go
Right.
to other states like DC or Philadelphia or even in New York, they have their own, but it's these building performance standards. So there's a whole host of different standards, but
Right.
just trying to become more operationally green in how you're running. And I think the hotel industry is not too far off, but they just need to marry those two, the booking and the back end side of things, and think about a little bit more about, the human operations.
So when you call on a client or a potential new client, are you talking to the building engineer folks, or who is your ideal person? And then whose door are in their business are you knocking on next to say, hey, let's blend these two things together?
Yeah, so it's typically a building owner. They're the ones that want to collect the rents and make sure the building's fully occupied. I always say a smart building is a fully occupied building that's running really efficient. That way it's making maximum dollars. But and if sometimes our way to an owner is through a property management company. So typically those are the first two ways to start. And then often they'll say, well, we want you to talk to our building engineers. And so you've got to win the trust of the building engineer that, we're not stealing your job. We're just there to have a hand behind your back And let's just face it, there's so much pressure on these engineers these days to perform. Can you lower the gas? Can you lower the water volume? We got to save on power. Geez, what do should we do solar? And that's a whole other. You mentioned solar earlier on.
Yeah.
It's people say, well, I'm going to spend money on solar before we make our building smart. And I said, okay, well, that's fine. There's some great incentives and all that stuff. But when you're going to the solar provider, he's now selling you more energy than you need because you're going off of your old, habits. And
Yeah.
you make the building smart. Now we've, tightened it up. We're saving 20, 25. In one building, we're saving 44% on power. I mean, it's just,
wow.
Cut the kilowatts by just an amazing amount. So, if you rather have it right sized, you start with us and then you right size it. And like I said, my partner did a lot of these Superfund sites was able to run everything on solar. So charge up the battery, run on the solar, run on the battery through the evening, and just have it where you're not really sucking a lot of power off the grid all the time. So you can, same thing with lighting. Lighting, if you can control the color of the lighting, you can put it in circadian rhythm. So in the morning, you got this nice, it's a red light that comes in the morning, and then the blue light in the afternoon. That's the other way around. Blue light in the morning and the red light in the afternoon. And that does some really great things for the health of people, So it's, these are things that aren't too far away for us to really generate some great lifestyle changes, healthy changes.
What is the big objection then? Okay, so I get like, hey, let's right size, then go to solar, and then maybe you pay for a lot of that solar with the surplus that we give you back. And even if you're not doing 44%, if you're doing 10%, I would imagine that you're covering a lot of the cost of the solar anyhow.
Yeah, so there's some great energy rebates out there for the solar companies. When you talk about smart buildings, it's so new and so cutting edge that there's this custom program that a lot of utility companies have, and some of them are pretty minor, checks, but they do pay, something. It's not like it's nothing. And then, yeah, gosh, just with the energy companies, it's really interesting. Like the toughest thing for us has been, it's a tough office environment. There's a lot of vacancy. People don't, I want to fill my space up and pay for TIs. I don't want to be, it's the cart in front of the horse, or there's lots of different theories and arguments there. I always say, if you could build a spec space for somebody, usually there's these spec suites are like 2,500 or 3,000 feet, and at $100 a foot, that's $250,000. Well, put InteliGlas in for $100,000, make it smart, save some money, and the money that you're going to save, obviously our paybacks are really, really fast. They're usually less than 20 months or 18, 15 months. It's pretty fast. But
yeah,
forget our payback, but if you can create the savings and put it towards tenant improvements for a future tenant, and then the whole novel idea of let's retain our tenants. And most tenants that have us are experiencing InteliGlas buildings are saying, wow, it is more productive. I'm actually being able to recruit better talent to work for us at the building, and so I'm not going to move.
Wow. Yeah.
So there's an aspect of keeping tenants in the building. But then when a tenant's actually out marching around and looking at a space, we give the brokers a look at it on their phone, and they can say, hey, the building's smart. This is what it has. We're reducing carbon, we're saving energy. That's important to a lot of people. Sometimes their decisions are based solely on that. But, if you can add a few other things to the pie, like, tenant utilization tools. So cubicle management, hot desking, because people are, no longer working 5 days a week. They're working, a couple days a week. And how do you not overlap the people where they're all, sitting on top of one another? So, we can manage those situations, through cubicle management and these tenant utilization tools that are out there. So the owner says, okay, well, I'll do that for you. I'll give you a RSVPing for your conference rooms, and you just pay me a nickel more or a dime more in rent. They're getting more rent. Boy, that's a win-win, and they're getting a tenant. And it's just a way of differentiating the building to the entire marketplace. So I don't think there's a lot of dart boards or billiard tables or ping pong tables that are, amenities are nice, but if you're going to come to work, I want you to work, and I want you to be productive, and I want you to be happy, and I want you to be in a good environment. And so let's just start there first. I guess I'm too old school like you. We're both, remember what it was 30 years ago at the work environment.
Yeah. I've worked, done odd jobs in a lot of like the Silicon Valley, especially San Francisco office spaces. And I see a lot of ping pong tables. No one using them really, but see a lot of that. See a lot of alcohol just laying around in the office. And I was like, wow, these guys haven't learned that, at some point people got to get to work. It's nice to get up and take a break, but if I'm taking a break, I'm leaving. I'm not staying here. Yeah. It's crazy. So one of the things that I've learned about technology and greening things is that there is a lot of chicanery and flim-flammery. And I'm not accusing you of this at all, but it is very common for a company to greenwash and say, hey, we said we were going to hit this goal of being carbon neutral, and looky here. We've done it. And really, there's very little accountability that can be had at that. And so I know for me, I'm instantly skeptical when I hear these things. I mean, Formula One is trying to become carbon neutral. And I'm like, there's not a fucking chance in hell. You flying race car teams around the world. I love Formula One, right? But there's no way they're offsetting all of that. They can tell me about how they've planned things, but you're going to have to show me how you've done that, because you're putting race car teams on tracks, then in airplanes, and then building carbon fiber car. But I don't believe it. So when companies say this, I know a lot of people are just like, I'm dismissive of that claim. So how do you get yourself out of that conundrum of being lumped in with this greenwashing thing that we all know that happens?
Yeah. It's one of our competitors was recently, they wanted to break a contract, and the customer who we were talking to, trying to sell, like, oh, we've heard this bag of goods before, and we just terminated with one of your competitors, and we don't believe in this technology. And so it's taken us a long while. I mean, we're going on year 6, and our story has gotten a lot better on how to tell the story and what we're doing, but we have a ton more data. For an example, we off of every building that's a 100,000 foot building, we're pulling out almost a little over 1 million bits of data on a daily basis. And it sounds like a lot, but then you start to stack it and compare it and look for anomalies and things like that. That's where it gets really interesting. And so we've now been able to determine, these things like where we're saving in overtime hours, or how we started the conversation, right?
Yeah.
And then we've let the Berkeley studies do their own speaking for air quality. Air quality is a big thing that's creates productivity in the work environment, and lighting is another. So we let those studies stand on their own, but it always comes down to how are you doing what you're doing. And so we've gotten to a point to where we can actually show graphically a building that runs on a BMS system, which is a building management system. Most buildings have them. And it looks like a little Richter scale. It's just going up and down because it's trying to move the heating and cooling set points pretty quickly through what they call K values. It's not taking into any consideration what the outside temperature is, or how many bodies are in the space, or what's what time of day it is, where the sun's at, all that stuff.
Yeah, just reactive.
And so now when I show it graphically, when a building's running on AI, it literally looks like these ginormous plateaus, and then it will go down, and then so people look at that and go, wow. And so when I zoom in on it, and I can show them, we move the set point up because the air outside is 55 degrees. So I don't need to turn the compressor on. I can just draw the outside air, and it's fresh air. And I'm going to make sure there's no pollutants in it. We're going to watch how we use the economizer, but we're going to use that. Well, in a 2-month period of time on one building, we saved almost $1,800 a month in power.
Come on.
It's crazy. Yeah. So though, and then the other notion is, AI is greater wear and tear on my equipment. Well, how is that possible if we're change a set point and the condenser is off and we're just running a fan? We're saving the condenser life of that is gone way down. You can utilize, Mother Nature into its truest form. Same thing at, nighttime with, California, we have these hot summer days, right? So you just close down the economizer. They're recycling the air inside. Well, if you have 200 bodies in the building, the CO2 levels get a little high. So at nighttime, when it cools down to 65 degrees, turn on the fan, bring in all the fresh air so the carbon goes down in the building, that type of thing. So these are just, they seem so common sense, but just at the end of the day, the engineer just runs out of time. And then there's a lot of buildings that don't have building engineers, of course. So,
well, there's that, right? Yeah. And then how much of an engineer do you have to be? Like, could you hire InteliGlas and put your system in there and you're like, hey, Dave, sit down here. Your job is engineer. And then they just learn how to manage the system. Is it smart enough to turn a lay person into somebody who can help run that building?
Pretty close. You'd have to know, some mechanical engineering side of things, with the dry points and so forth for air conditioning. Lighting's not so much technical, and same with elevators. But there are big, publicly traded REITs that are running engineers for multiple buildings, and they're still having them drive, right? So I'm going to give you 4 buildings, but you're in LA, you're going to have to drive, it's only a half an hour. Well, it's only a half an hour when there's no traffic.
Right.
Going to 4 different buildings and trying to run it. So now on a single pane of glass, that's how we get InteliGlas. And by the way, glass, GLAS, is Gaelic for lock. So we actually harden the asset, as I mentioned earlier. Yeah. But we give a little map, and so they can click from building to building that they have, and you don't have to roll, from computer screen to computer screen, as we call a rolling chair syndrome. It's there all the time. So you can go to Florida, to Chicago, to Boston. You can bounce around from building to building, and you don't have to be there. Yeah. So I think that's the new way. That's definitely something that's going to be occurring more in the future.
Yeah. One of the things that I'm from a refinery town, and one of the things those guys do is we've reached this many hours, and they start testing vibration and that kind of thing on different pieces of equipment. And then before it fails, because it's a refinery, they swap it out, because they can't have this generator fail because it's critical to the function of, even though there's redundancy, you still have to maintenance these things ahead of failure. And not all companies have that kind of demand, but it seems to me you guys could have some kind of sensor that's like, hey, we're getting a little bit of wobble in this compressor, and look, there's compressors all over a giant building. There's all kinds of things that rotate and fans that cavitate and all these things where, hey, it seems like we're going to have to replace this fan soon. There must be a bearing that's bad or whatever it is, right? And just walk Dave up to the top of that building, not on a ladder, and just have him go, do a little blowout of that air conditioner or whatever it is, right? Because sometimes it's just that alert that might save you a lot of money on maintenance or replacement,
Yeah. Anomaly detection. That's exactly.
Yeah.
It's expensive. I could put a sensor on every motor at $650 to $700 per motor. It just gets super, super pricey. So what we try to do is we watch the amperage going through the building. and so we through the pump or the
Mm-hmm.
fan. So we'll look at that and pick up an anomaly that way. We're in the process of generating an ear. So we'd put it into an equipment room, and it would pick up the sound signatures. So it'd be like listening to an orchestra. And so
Sure.
there's a French horn, there's the trombone, there's the violins, there's the piano. It would pick up all these signatures that are being played in the room.
Yeah.
And once there's an anomaly that occurs, it would, we would be able to detect it. And so I just need someone to come along and invest a little bit more money with us to finish that part of the puzzle out. But we have somebody out of Montreal that's got the technology to do it for us. We just need to kind of finish it out with them. So it makes it now I can do 7 pieces of equipment, not at $700 per 7.
Yeah.
I can do it at probably $700 for 1 to get 7. So the cost of it comes down.
Yeah.
And that's the idea, is to do as much as possible with as little hardware and installation. Our installs only physically take 2 days to install in the building. And after that, to commission everything onto our platform takes another 2 to 3 weeks. So I think people are amazed that, the first month when they turns on, it's like, am I going to see it in the first month? Yeah, you can see it.
Yeah. Well, I don't want to take too much more of your time because I know you're busy and everything else. And I don't know who you would need to talk to, but I know that Bill Hornbuckle is the MGM Casino CEO. So let's say we sat him down right here. What would you want to tell him or somebody else, and just like use this time to kind of pitch what you do so that when someone finds this, they hear exactly what you want them to hear?
Yeah. So the hotel space is not an area that we're expert in because of, as I mentioned, the 2 different softwares, the booking side and the operational sides. But anybody that's running a corporate facility, 30,000 square feet or more, wants to make a difference on the planet Earth, we're that's where we can go in inexpensively, retro commission these buildings very fast, be non-disruptive to the tenants that are existing. And even buildings, the biggest pushback of lately has been like, hey, I don't have anybody in my building and there's a lot of vacancy. Well, let us help you bring people back to the building. Let's differentiate your building in the marketplace by making it green and branding your building differently out there in the marketplace that you care. And by the way, despite the building being 50% occupied or 100% occupied, the way that the engineers calculate these buildings to run is, I have a 60-ton air conditioning unit and it runs with 100 people all the time, and it runs full speed all the time. So to be able to slow those down or put the air in the right places where the bodies are, that's the magic. And
that's the magic. Yeah.
So that's key.
InteliGlas, InteliGlas.com. That is Scott right there. He's the man that knows all this stuff. If you have any interest in that, let him know. Man, it's always interesting to learn different things about what people do. And I appreciate you coming on. Anything you want to ask or say before we wrap this up?
Pete, I really appreciate the time and the energy. We've talked a little bit about what we're doing. We're both, we're human beings. We're putting on our pants one leg at a time. We're just trying to make a difference so that our grandkids and great grandkids and the future has got something to look back at it and be proud of. And I think part of it is thinking green, but the other aspect of it is actually being proactive and doing something and shaping behaviors, and that's what's needed in today's society, I think.
Yeah. Well, like Kermit said, it ain't easy being green.
Hey, thanks for watching the show. I really appreciate it. Right here, you can subscribe. Please do that. It makes the show grow. Hit that notification bell so you know which incredible guest is coming up next. Down below is the PayPal link. You can put a small subscription in. That is an enormous help. All that money goes right back into the show. And then right up over here are the next episodes you should listen to, curated by your